This is about how to write the formula of ions. Okay, so real quick review. Ions are basically atoms that have become charged by losing or gaining electrons. So for example, if we have something like sodium, Na, it has 11 protons, 11 electrons, and it has one valence electron. So sodium has this one valence electron inside our shell, and in order to get a full shell, it either has to gain 7 or lose that 1, and it's easier to lose that 1. And so when that 1 electron goes away, it no longer has 11 electrons, it has 10 electrons. And so you have 11 protons and 10 electrons, and the protons are positively charged, and so you have one extra proton, and it gives the sodium ion a positive charge. Okay, so an ion is simply an atom that has become charged, and so you'll have the symbol for the atom, for the element, and then you'll have the charge. The charge is typically going to be a superscript on the upper right side of the symbol. Okay, remember metals tend to form positive ions and nonmetals tend to form negative ions. And so if we look at some ions here at group 1, you'll notice they all have a +1 charge because they all have one valence electron. If we look at for group 2, they all have a +2 charge because they have two valence electrons. They've lost 2 electrons. Group 13, they have 3 valence electrons. When they lose those 3, they get a 3+ charge. I'm skipping over the transition metals for right now because they can form more than one ion. They have some special rules we have to follow for those. Group 14 is right in the middle. Since they have 4 valence electrons, they can either lose 4 electrons or they can gain 4. Well, the metals, they tend to lose 4 electrons, so they're going to have a +4 charge. The nonmetals, they gain electrons, so they're going to have a 4- charge. So like tin and lead, they will have a 4+ charge, while carbon will have a -4 charge. Your group 15, the nitride and phosphide ions still have a 3- charge. And then oxygen and sulfur, your oxide and sulfide, have a 2-. They have 6 valence electrons, so they're gaining 2 electrons. Then group 17, they have 7 valence electrons, so they're going to gain 1, so they'll get a -1 charge. So your chloride, bromide, fluoride, iodide. And of course, group 18, they already have a full outer shell, so they do not form ions. Now, if you're using a periodic table and you need to figure out what, you need to write the ion for an element, you're going to have to basically go along and figure out what the charge is, and it's based on the group. So everything in group 1 is a +1 charge. Group 2 is +2. We're skipping over the transition metals. Then 13 is +3. Group 14 is +4 if it's a metal and -4 if it's a nonmetal. Group 15 is going to be -3. Group 16 -2. And group 17 is -1. So for example, if I wanted to figure out what the charge or what the ion for strontium is in group 2 right here. So it'd be Sr for the symbol and then +2 for the charge. Okay. Transition metals. These are the ones in group 3 through 12. These typically can form more than one ion. Okay, so for example, iron can form a +2 or a +3 ion. And so we use these Roman numerals to represent the charge. And so if I have the name of the ion, like iron 2 ion, I know it's Fe, the symbol for iron, and then the charge is +2. Same thing with iron 3. It's going to be Fe for the symbol, and then +3 for the charge. So whatever that Roman numeral is, that is the charge on the transition metal ions. Now some transition metals don't use Roman numerals. So these are going to be the transition metals where the name doesn't have a Roman numeral. For example, the most common There are some more others than these, but the most common are going to be silver, zinc, cadmium, bismuth. Okay, so to write a transition metal ion, you write the symbol, and then whatever the Roman numeral is, you write that as a superscripted charge. So, for example, the cadmium ion, this is one of the ones that doesn't have a Roman numeral. We just have to memorize that cadmium is a +2, so it's going to be Cd with a +2 charge. Okay, cobalt-3 ion, so cobalt symbol is Co, and then the charge is a 3 because it's a Roman numeral 3, so it's a +3. Then manganese-2 ion, so manganese is Mn, and it's a +2 charge. We get that from that Roman numeral. For polyatomic ions, the way that you can recognize a polyatomic ion is going to be an ion with more than one atom in it, more than one element. Okay, because polyatomic ions are basically a group of atoms that are covalently bonded together, and so that molecule behaves like an ion. So, for example, ClO3 with a -1 charge, that is a chloride ion. That is a polyatomic ion. There's one chlorine atom covalently bonded to 3 oxygen atoms, and they end up with an extra electron, so it has a -1 charge. Here is the list of polyatomic ions. You basically either have to have that list, that chart, or you have to memorize it.